we need to prove the following. So let's begin from the left hand side. So here on the left hand side, we are given sine theta raised to the power of 6. Now sine theta raised to the power of 6 can be also expressed as sine squared theta whole raised to the power of 3. Plus we have cosine theta raised to the power of 6, which can be also expressed as cosine squared theta whole raised to the power of 3. Now we're going to use the identity that whenever we have a cubed plus b cubed, it can be expanded as a plus b multiplied to a squared minus ab plus b squared. So in our case, the a value that's represented by sine squared theta and b value is given by cosine squared theta. So we'll take the help of this side of the given identity, and we're going to replace the value with a and b with sine squared theta and cosine squared theta respectively. So let's begin. So this means we are going to have a plus b, so that's sine squared theta plus cosine squared theta whole multiplied to, so we have a squared. So a squared will be sine theta raised to the power of 4 minus ab. So ab will then become sine squared theta times cosine squared theta plus b squared. So b squared means we have cosine theta whole raised to the power of 4. Now luckily sine squared theta plus cosine squared theta, this is a standard identity with a value of 1. So that means we now have sine theta raised to the power of 4. So we will have sine 4 theta minus sine squared theta times cosine squared theta plus cosine theta raised to the power of 4. But we can express cosine theta raised to the power of 4 as cosine squared theta whole squared. Means exactly the same thing. This is done so that we can replace, let's write down the first two terms. We have sine theta raised to the power of 4 minus sine squared theta times cosine squared theta. What we want to do is we want to convert this cosine squared theta to something in terms of sine squared theta. So we know that sine squared theta plus cosine squared theta, that's equals to 1. So cosine squared theta will be 1 minus sine squared theta whole squared. This was going to give us sine theta raised to the power of 4 minus sine squared theta times cosine squared theta. Now we're going to expand this 1 minus sine squared theta whole squared using a minus b whole squared. So we're going to get 1 squared minus 2 times 1 times sine squared theta, so that's simply 2 sine squared theta plus b squared, which is sine squared theta whole squared. So that means we have sine theta raised to the power of 4. Now we can combine the last term and the first term. So this is going to give us 2 times sine theta raised to the power of 4. Then we are going to consider next term as negative 2 times sine squared theta plus 1 minus sine squared theta times cosine squared theta. Now we can combine the first term and the second term by taking negative 2 sine squared theta as the common factor. So we have negative 2 sine squared theta. If we take it common, we're going to get negative sine squared theta plus 1 plus we have 1 minus sine squared theta times cosine squared theta. Here again we have 1 minus sine squared theta, which can be replaced with cosine squared theta. So we have negative 2 times sine squared theta times cosine squared theta plus 1 minus sine squared theta times cosine squared theta. Right. So negative 2 times sine squared theta cosine squared theta, this gets added to the third term, and this is going to give us 1 minus 3 times sine squared theta multiplied to cosine squared theta, which is the expression on the right hand side. Hence we have successfully shown that the left hand side of a given equation, thus left hand side is equals to the right hand side, and we have successfully proved it. Hence proved.